Good morning, everyone. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Halyard. In the previous class, we were discussing about half-range Fourier series. What's the difference between full range, half range we have discussed in the previous class. So, what's a half-range Fourier series? Half-range Fourier series. What's half-range Fourier series? Suppose till now we were discussing about periodic functions with period 2 pi, and when we discussed arbitrary period we had considered the period to be 2l. So this is a full range. Suppose if we consider and define the periodic functions in the half range, that is defined in the interval 0, L or 0, half the interval, then such Fourier series is nothing but half-range Fourier series, which is defined half the interval. Such functions are known as half-range Fourier series. And what Fourier series expansion we get it from them? They are known as half-range Fourier series. And we have discussed the general form of half-range Fourier series. We have two types here. We specifically need to have the Fourier series in terms of either sine terms only or cosine terms only. Okay, here we will have either sine terms or cosine terms only. Then it becomes necessary to have the function as either even or odd, because we have discussed in the previous classes that in order to have the sine terms we should have the function to be odd, because when the function is odd we will have both an and a naught equal to 0. That time Fourier series expansion will be summation n equal to 1 to infinity bn sin nx in the interval 0, 2 pi. Okay, when we are discussing about this one, full range. And suppose if the function is even, if in that case bn is 0, so we have the Fourier series expansion to be f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx in the interval 0, 2 pi. So depending on that we find the Fourier coefficients and we get the Fourier series expansion. But here in half-range Fourier series, sometimes it is required to have the Fourier series in terms of either sine and cosine only. So when the sine term we require, we need to use this Fourier series expansion. When we need to have the Fourier cosine, that time we have to use this formula in order to find the Fourier series expansion, which contains only cosine term. Then we need to find the respective Fourier coefficient. So this is what we have learned. We have also asked few questions based on finding half-range sine series and half-range cosine series. So let's discuss few more examples in this class. So let's find the cosine half-range series. Cosine half-range series of f of x is equal to x sine x in the interval 0, pi. Cosine half-range series of x sine x in the interval 0, pi, and we have to deduce that to 1 by 1 into 3 plus 1 by 3 into 5 minus plus 1 by 5 into 7 minus etc. pi minus 2 by 4 equal to pi minus 2 by 4, or this can also be written as 1 plus 2 by 1 into 3 plus minus 2 by 3 into 5 plus 2 by 5 into 7 etc. that is equal to pi by 2. Either these both are same, you can deduce to either one of them. So first thing they have asked cosine half-range series. So cosine half-range series of the function in this interval 0, pi, it is given by f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx, because half-range cosine series they have. So it contains only cosine term. So we need to find the Fourier coefficients a0 and an. Let's find a0. a0 is given by 2 by pi integral 0 to pi f of x dx, that is equal to 2 by pi integral 0 to pi. F of x is what? X sin x, x into sin x dx. Let's integrate it. 2 by pi. How do we find the integration of this? How to find the integration of this? You can use Bernoulli's rule. First term into integration of sin x. Integration of sin x is minus cos x. Minus differentiation of x is 1. Integrate this again minus sin x. And the limits will vary from 0 to pi. Easiest way is to apply Bernoulli's rule in order to find the integral of product of two functions. Let's apply the limit. What do we get? 2 by pi, and you can say that this is going to be 0 because sin pi and sin 0 are 0. So what we will have over here, if you take the minus sign outside, it is x cos x. So upper limit is pi cos pi minus 0 because 0 into cos 0 will be 0. So what we will have over here, cos pi will be minus 1. So pi get cancels, a naught value is 2. So what will, sorry, a naught is 2, a naught by 2 will be, is it clear everyone? Apeksha, is it okay?
Yes, ma'am.
Let's what's the formula for an? An is given by 2 by pi integral 0 to pi f of nx dx. So that is equal to 2 by pi integral 0 to pi f of x is x sin x, f of x is x sin x cos nx dx. Now, what shall we do over here? What shall we do in order to find the product of integral of this term? 2 by pi integral 0 to pi x, I'll keep it as it is. I apply sin a cos b formula for sin x cos nx. What we do? Apply sin a cos b formula for sin x cos nx. So it is what? Half times sin a plus b. So sin x plus sin nx. We will have, it will be sin x plus nx a plus b plus sin a minus b, x minus nx into dx. Is it okay everyone? A plus b into a minus b. Formula,
Yes,
a plus
ma'am.
b into a minus b. So that is equal to, here 2 get cancels, 1 by pi into integral 0 to pi x into, see here you can take x outside, sin n plus 1 into x. From this if I take x outside, 1 plus n into x it will become, so 1 plus n plus 1 into x. Similarly over here, from this if I take minus x outside, what happens? Minus sin n minus 1 into x dx. This simplification we have done 2 to 3 times. I hope you all remember. Yes, this kind of simplification we have done at times. Remember? No? Don't remember? Nobody remembers this? Nikita?
Yes, ma'am.
Okay. See this, we have done this similar before as well. Now if I take minus x from this outside, what remains? Minus n minus 1 into x remains. Now next what shall we do? What shall we do next? You write this separately. 1 by pi into integral of 0 to pi multiply x. So x into sin n plus 1 into x minus integral 0 to pi x into sine n minus 1 into x. So the entire term dx into dx. I have multiplied x with both of this. Now here you have to apply the product rule in order to integrate the two terms. So that is nothing but 1 by pi into integration of these two terms. It will be first term into integration of second term. Integration of sine is minus cos n plus 1 into x divided by n plus 1. Okay, you have to apply separately product rule for this term as well as this term. So first term into integration of second minus differentiation of x, that is 1, integrate this one. So integration of that is minus sine n plus 1 into x divided by n plus 1, and it over, because after if you differentiate 1 again it will be 0. So this is the first term. Then minus, apply for this one, limits vary from 0 to pi. For the second one, first term into integration of sine n minus 1 into x. Integration of sine is minus cos n minus 1 into x divided by n minus 1. Minus differentiation of x, that is 1. Integrate this again. So integration of that is minus sine n minus 1 into x divided by n minus, here it will become square, isn't it? N minus 1, here also n minus 1 whole square, and the limits vary from 0 to pi. Is it okay everyone? Anybody has any doubt in this step? Please go through this step once again. Work out along with me, because we have solved quite a few 2-3 problems. So now onwards you can try solving on your own. Check if you have any doubt. Anybody, any doubt? Anybody, any doubt?
No, ma'am.
Prajwal, is it clear?
Ma'am.
Okay, let's continue this then. Now, apply the limit. So what we get when we apply the limit? Apply the limit over here, what do we get? And remember this is true for n not equal to 1. So what do we get over here? An is 1. Okay, put the limit pi. So this is however going to be 0 for both upper and lower limit. Here also it is going to be 0. So here we need to apply only for the cosine term. So it is nothing but minus 1 by n plus 1. Keep this constant term separately. Minus 1 by n plus 1. Apply the limit for x. It will become what? Pi cos n plus 1 into pi. If you put the lower limit, it is going to be 0. Okay, then come to this stage here. Here you have a negative sign, minus of minus will be plus 1 by n minus 1 into, apply for this one. What do we get? Pi cos n minus 1 into pi. When you apply the lower limit, it is going to be 0. Is it clear everyone? Anybody has any doubt? Please ask. See, this term is going to be 0. Similarly, sine term is going to be 0. Here what do we have? Minus by n plus 1. Minus 1 by n plus 1, which I have taken outside. X into cos n plus 1, x remains. For that you put the upper limit pi, lower limit 0. It will become pi into cos n plus 1 pi. When you put the lower limit, it is going to be 0. Cos 0 is 1, but this x is there. So it will become 0. Similarly, this term will be 0. When you come over this term, similarly what happens? Minus of minus, here there are two minus sign, it will become plus 1 by n minus 1. Put the upper limit pi, so pi cos n minus 1 pi. Lower limit is 0, so it is going to be 0. So next, what do we get from this? Just check. What do we get? See here, there is pi term, and here also pi term. So if you cancel out this pi with this pi, Okay, you can cancel out that pi. This pi get cancels over here when you take the LCM. So what is remaining now? Just check. Minus cos n plus 1 into pi divided by n plus 1. And here cos n minus 1 into pi divided by n minus 1. So these are the things which remain. And we know what is cos n plus 1 into pi. Let's substitute that. Minus 1 into cos n plus 1 into pi is minus 1 power n plus 1 divided by n plus 1 plus cos n minus 1 into pi is minus 1 power n minus 1 divided by n minus 1. Is it okay, everyone? Anybody any doubt in this? Is it okay? Are you able to understand or no? Please reply.
Understanding, ma'am.
Okay. What do we do here? See over here. Minus 1 power n plus 1 into minus 1 power n. It 1 can be written as minus 1 power n plus 2. Here minus 1 power 1 is there. So it will become minus 1 power n plus 2 and minus 1 power n minus 1. So I can take minus 1 power n outside. If I take minus 1 power n outside, what remains? Minus 1 power 2 divided by n plus 1. And here what remains? Minus 1 power minus 1 remains divided by n minus 1. Remember this, minus 1 power n plus 2 can be written as minus 1 power n into minus 1 power 2. Similarly, minus 1 power n minus 1 can be written as minus 1 power n into minus 1 power minus 1. So this is what I have written over here after taking the common minus 1 power n. So we have over here minus 1 power n, minus 1 whole square is 1 divided by n plus 1. Similarly, minus 1 power minus 1 is minus 1. So we get this here. Now take the LCM and simplify. What do we get? An as an is nothing but minus 1 power n. If you take the LCM over here, n plus 1 into n minus 1. So it will be n square minus 1. LCM is n minus n plus 1. So plus n minus n get cancelled. So we will have minus 2. Minus 2 into minus 1 power n divided by n square minus 1. Here we will have minus 1 minus 1. Minus 2 into minus 1 power n divided by n square minus 1. Anybody has any doubt? This can also be written as 2 power minus n plus 1 divided by n square minus 1, because here minus 1 power 1 is there. So it can be written as minus 1 power n plus 1. Anybody any doubt? And this is true for the case when n is not equal to 1. Anybody has any doubt in this problem? Till here, anybody has any doubt? Please answer.
No, ma'am.
Okay. So an is, we got it when n is not equal to 1. So let's find when n equal to 1 what happens. We need to find when n equal to 1. That is, we need to find what is a1. How do we find a1? Same formula as an, but n has to be replaced by 1. So it will be 2 by pi integral 0 to pi x sin x cos nx was there. N is 1, so it will become cos x dx. So that is equal to 2 by pi integral 0 to pi x into sin x cos x can be written as sin 2x divided by 2. There is a formula sin 2x 2 sin x cos x. So sin x cos x will be what? Sin 2x divided by 2. So here it is sin 2x divided by 2 into dx. Next, here see this 2 get cancelled. So what is remaining? 1 by pi integral 0 to pi x sin 2x dx. So now we can apply the product rule over here, that is using Bernoulli's rule. So 1 by 2 pi into first term x into integration of sin 2x. Integration of sin 2x is minus cos 2x divided by 2. Alternatively positive and negative signs, so minus differentiation of x, that is 1. Integration of minus cos 2x, it will become minus sin 2x divided by 2, and the previous 2 is there, so it will become 4. And we stop it over here only, because when you go to the next step you have to differentiate 1, and differentiation of 1 will be 0. Limits will vary from 0 to pi. And we know for sine this is going to be 0. This term is going to be 0 because sine n pi and sine 0 are all 0. So what will be a1? You can take this 2 outside, so we will have 1 by 2 pi, minus also we can take minus sign outside, so we will have x cos 2x, limits vary from 0 to pi. So this is nothing but minus 1 by 2 pi, put the limits, pi cos 2 minus lower limit is 0. So we will have here cos 2 pi is 1 and pi get cancelled, so we will have minus 1 by 2. So this is the value of a1. So what is a1? Minus 1 by 2. Is it okay everyone? Anybody has any doubt? Anybody any doubt? Anybody any doubt? This problem is similar problem. We have defined over here I naught sin t. I naught mod sin t. Similar problem simplification is only this one. But values are little different. Is it okay?
Yes, ma'am.
Okay. Now, next, what we have found out now, a naught, an and a1, because an is for n not equal to 1, that's why we have found out what is the value of a1. Let's substitute in the given Fourier series. What's the Fourier series expansion? F of x is equal to, what is it? What is it? Here it is. See, f of x is equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. So what is a naught by 2? A naught by 2 is here. A naught by 2 is 1. A naught by 2 is 1. So I'll write it over here once again. A naught by 2 plus summation n equal to 1 to infinity a n cos nx. Okay, so right, let's substitute a naught by 2 is 1 plus summation. First see over here, it is, we'll write it for n equal to 1, a1. So a1 it is what? Minus half, minus half. Now summation, it starts from 2, n equal to 2 etc. up to infinity. What is an? We have found out, it is 2 into minus 1 power n plus 1 divided by n square minus 1. So it is nothing but 2 into minus 1 power n plus 1 divided by n square minus 1 into cos nx. So what do we get from this now? What is this? This is our Fourier series expansion. This is our Fourier series expansion. Now look that they have asked us to deduce it too. What is it? They have asked pi minus 2 by 4 equal to what we have to prove? Pi minus 2 by 4 equal to 1 by 3 minus 1 by 3 into 5 plus 1 by 5 into 7 etc. We need to deduce the expression, deduce the Fourier series expansion. So in order to deduce that Fourier series expansion of this form, what we do is we put x equal to pi by 2. Put x equal to pi by 2 in the Fourier series expansion. What is f of x? F of x is x sin x. So what is f of pi by 2? F of pi by 2 will be pi by 2 sin pi by 2. And we know sin pi by 2 is 1. So pi by 2 into 1 is pi by 2. So let's substitute x equal to pi by 2 in this Fourier series expansion. F of pi by 2 is pi by 2. We got it over here. So that equal to, what do we get? 1 minus half. Am I correct? What is 1 minus half? What is it? Can we write it? Yes. What is 1 minus half? Don't know. Is it? Wait, here there is a little mistake has happened. See over here, in this Fourier series expansion, a naught by 2 is 1, correct? A naught by 2 is 1, and here in this an cos nx, we are writing a1 cos x separately plus summation n equal to 2 etc. up to infinity an cos nx, because this cos x is missing over here. So it will a1 is minus half cos x. Is it okay everyone? Is it okay? Is it okay? Are you all following? Why no response from anyone?
Yes, ma'am.
Is it confusing?
No, ma'am.
No,
Okay.
ma'am.
I hope you understood this. We'll write it once again. So let's write it once again. Let's write it once again. See over here, f of x is equal to a naught by 2, we got it to be 1 plus, we have an for n not equal to 1. We have an for n not equal to 1. For n equal to 1, we got it a1 to be minus half. So for n equal to 1, you should take outside. So it is nothing but a1 cos x plus summation n equal to 2 to infinity. 2 to infinity an cos nx. So what is it going to be? You have to substitute now. So we get it 1 and a1 is minus half cos x plus summation n equal to 2 to infinity an. What is an? What is an? Here we have got it an. 2 into minus 1 power n plus 1. 2 into minus 1 power n plus 1 divided by what? N square minus 1. N square minus 1 cos nx. I hope this is clear. This is the Fourier series expansion. Now in order to deduce that to the given expression, let's put x equal to pi by 2, and we know f of x equal to x sin x. So f of pi by 2 is pi by 2 sin pi by 2. Sin pi by 2 is 1, so this is pi by 2. So let's substitute in this expression, that is star. F of x is what? Pi by 2. So we have to put x equal to pi by 2, and cos pi by 2 is 0. So this term is going to be 0. So we will have 1 and then plus, you can take 2 outside. 2 into summation n equal to 2 to infinity minus 1 power n plus 1 divided by n square minus 1 cos nx. We have to put x as pi by 2. So what do we get over here? Cos n pi by 2 we get. Am I correct? Is it cos n pi by 2 we need to substitute over here. Next, what do we do next? What do we do next? So that is equal to this one, you take to the other side, it will become pi by 2 minus 1, that is equal to 2 times summation n equal to 2 to infinity minus 1 power n plus 1 divided by n square minus 1 into cos n pi by 2. Or you can also, here you can take the LCM. It will become, when you take the LCM, it will become pi minus 2 divided by 2 into this half. It will be 1 by 2. That is equal to summation n equal to infinity minus 1 power n plus 1 divided by n square minus 1 into cos n pi by 2. Check if you have any doubt in this, everyone. Everyone check for a minute. Everybody. Is it okay? Shall I continue? Bhagyashri, any doubt?
No, ma'am.
Okay. So what do we get from this now? That is pi minus 2 by 4, that is equal to pi minus 2 by 4, that is equal to, now next, that is equal to what we have over here. Expand this for give different values for n. What happens then? Give different values for n. We will have over here summation n equal to 2 to infinity minus 1 power n plus 1 divided by n square minus 1 cos n pi by 2. See over here, when you give here even numbers, when you give even numbers, what happens over here? We will get either cos pi, even numbers, say 2. If you give 2, 2 to get cancels, pi will remain. If you give 4, what will remain? 2 pi. Similarly, cos, if you put 3, even number 6, 3 pi. So only if when you put even numbers, in place of n, when you put even numbers, you will get cos pi, cos 2 pi, cos 4 pi, etc. And we know the values of them. What are the values of them? Just substitute over here for cos n pi by 2. Starting from n equal to 2, 4, 6, 8, etc. And similarly, cos n pi by 2, put n equal to 3, 5, 7, etc. and check what will be the cos n values. So here if I put n equal to 2, if I put n equal to 2, what do I get? Cos pi I get, n equal to 2 cos pi, n equal to 4 I get cos 2 pi, next n equal to 6 I get cos 3 pi. What is the value? What are the values of this? What are the values of this?
Plus 1 and minus 1.
Plus 1 and minus 1. Similarly over here what happens when you give n different odd values? Cos 3 pi by 2, cos 5 pi by 2, cos 7 pi by 2. What are the values of this? What are the values of this? Cos 3 pi by 2, cos pi by 5 pi by 2 and etc. This will be 0. This will be 0. Now substitute these over here. What do we get? Pi minus 2 divided by 4, that is equal to, see, for all the odd numbers it is going to be 0. So we start from even number, that should be start from 2. So what happens over here? Minus 1 power 2 plus 1. So minus 1 power 3. So it is what? It is going to be negative divided by 2 square minus 1. So 2 square minus 1 is 1 and cos pi we get. Cos pi is minus 1. So it will be what? Tell me the answer over here. Just substitute n equal to 2 over here because for all the odd numbers it is going to be 0. Check only the even numbers. Put only the even numbers. So for this one minus 1 power n plus 1 divided by n square minus 1 cos n pi by 2. Only put even numbers. When you put 2, what happens? Minus 1 power 2 plus 1 divided by 2 square minus 1 cos pi, because 2 get cancels. Cos pi is minus 1. Minus 1 power 2 plus 1 is also minus 1. 2 square minus 1 is 3. So minus 1 into minus 1 divided by 3 is 1 divided by 3. Is it okay? Is it okay?
Yes, ma'am.
Okay, next put n equal to 4. So minus 1 power 4 plus 1 divided by 4 square minus 1. That into cos 4 pi by 2. Cos 4 pi by 2 is cos 2 pi. Cos 2 pi is plus 1. Minus 1 power 5 is minus 1. 4 square. 4 square is 16 minus 1. So it is 15. So minus 1 into 1 by 15, which is minus 1 by 15. Next, go for n equal to 6. So what happens when you put n equal to 6? Minus 1 power 6 plus 1 cos 6 pi by 2. So cos 3 pi divided by 6. 6 square is 36 minus 1. N square minus 1. So here we will have minus 1 cos 3 pi is minus 1 divided by 35. So we will have plus 1 by 35. So what is 5 minus 2 by 4? It is 1 by 1 into 3 minus 1 by 3 into 5, because 15 can be written as 3 into 5, plus 1 by 35 can be written as 5 into 7 minus etc. This is the deduction we are supposed to do. Anybody has any doubt in this? Anybody has any doubt in this? Go through this formula once again. And they have asked one more part over there. Either you reduce it to this part or check this one. This can be written as 5 by 4 minus 1 by 2. Am I correct? When you split this, you can split this as, is it pi by 4? Am I correct? Is it correct?
Yes, ma'am.
Okay, you can also write like this, but what they have asked, you have to rearrange in this 2 into this form. So in order to get to this form, what we do, we multiply by 2. First we will multiply by 2. So in order to get to that form, we multiply by 2 on both sides. So if you multiply by 2 on both sides, we get pi minus 2 by 2, that is equal to 2 into 1 by 3 minus 2 by 3 into 5 plus 2 by 5 into 7 minus etc. Now you take this pi by 2, 2 by 2 will be minus 1, that is equal to 2 by 1 into 3 minus 2 by 3 into 5 plus 2 by 5 into 7 minus etc. So pi by 2 will be minus 1, take it to the other side, it will be 1 plus 2 into 1 by 1 into 3 minus 2 by 3 into 5 plus 2 by 5 into 7. So this is the second deduction they have asked us to do it. Either you can stop till over here or you have to continue till over here. Anybody has any doubt in this? Please ask. It's a quite lengthy problem, but this has asked once in the question paper. See, most of the questions I discussed, they have repeated in the question paper itself. So just go through this in the notes and check. You will find it easier if you work out along with me. If you just sit and listen, it cannot be that effective. Is it okay?
Yes, ma'am.
Okay. So let's discuss. We have discussed only one question. Let's discuss the next question. Obtain the sine half range series of sine half range. So we have discussed previously cos. So sine half range. Sine half range series of pi by 2. Wait. F of x is equal to 1 by 4 minus x in the interval 0 and pi by 1 by 2, x minus 3 by 4 in the interval half less than x less than 1. So this is the function which is given to us, and check f of x is defined in the interval 0, 1. It is defined in the interval 0, 1. Half lies between 0 and 1. It is split into two parts, but you can say that f of x is defined in the interval 0, 1. Now compare that with the half range. Our half range is for interval is 0, L. So on comparing, we get L value to be equal to 1. So what is the corresponding sine half range series? F of x is equal to summation n equal to 1 to infinity bn sine n by x by L. Okay, so what is it? Summation n equal to 1 to infinity bn sine n by x, because L is equal to 1. They have asked sine half range series, so we have to consider this one because it should contain only sine term. Now what do we need to find? We need to find the value of Bn. What is Bn? How Bn is given by? It is given by 2 by L integral 0 to L f of x sine n by x by L into dx. We know L is 1, so it will be 2 by 1 integral 0 to 1. What is f of x? Now check. Where is 0 to 1? 0 to 1, see here 0 to 1, but it is split into two parts. So the integral also let us split into two. First part is from 0 to half. When x lies between 0 to half, function is 1 by 4 minus x into sine n by x, plus when it varies from half to 1, it is x minus 3 by 4 sine n by x into dx. So this is the thing. We have from 0 to 1, so you split into two parts. Now let's evaluate this. What do we get on evaluating this? What is Bn? We get it from here. What is the value of Bn? It is 2 times. Check this once again. You have to apply product rule for this. So first term 1 by 4 minus x into integration of sine n by x. Integration of sine is cos n by x divided by n pi. Minus differentiation of this. Differentiation of that, it is minus 1. Integrate this once again. So integration of that is minus sine n pi x divided by n pi, and this n pi is already there, so it will become n pi square. So this is with respect to the first one. Now take this one, and the limits vary from 0 to half. Take the second part. It is x minus 3 by 4. It's x minus 3 by 4. So what do we get over here? First term, x minus 3 by 4 into integration of sine. What is integration of sine? Minus cos n pi x divided by n pi. Then minus, differentiate this. Differentiation of this is 1. Integrate this again. We get minus sine n pi x divided by n pi whole square. And the limits vary from half to 1. Is it okay, everyone? Anybody has any doubt?
No, ma'am.
Okay. Let's evaluate this by putting the limits. So what do we get over here? 2 into minus 1 by n pi. Put the limits. What do we get when we put the limits? Upper limit half. Half here if you put it. What do we get? 1 by 4 minus 1 by 2. What it is? 1 by 4 minus 1 by 2. What is 1 by 4 minus 1 by 2? Answer me. Is it so difficult? Are you
Minus
there?
1 by 4, ma'am.
Okay. minus 1 by substitute. I'm substituting the upper limit. What happens next? Minus 1 by pi n pi are taken outside. I have substituted 1 by half to this. So here it will become cos n pi by 2. X is half. Okay, next. Here what happens? Minus minus minus. What happens over here?
Minus only, ma'am.
Minus. And next, sin n pi by 2. What will be sin n pi by
What?
2? Is it?
Yes, sin n pi by 2.
1 by n square pi square sin n pi by 2. Am I correct? We get sin n pi by 2. This is the upper limit. Is it confusing? Okay, let me write once again. Okay. Let me write once again. See, 2 into 1 by 4 minus x. I'll write it once again. Minus 1 by n pi. You have 1 by 4 minus x cos n pi x. Okay, so this is the first term you have over here, and the limits vary from 0 to half. Okay, next over here minus, you have 1 divided by n square pi square sin n pi x, limit vary from 0 to half. Okay, this is the first term. Now take the second term plus x minus 3 by 4, minus term is there, minus cos n pi x divided by n pi, limits vary from half to 1. In minus and minus is there, it will become plus 1 by n square pi square sin n pi x, limits vary from half to 1. Even this question is been asked in the question paper. You work out along with me so that it will become easier for you all. So here what do we get? We get 2 into minus 1 by n pi. You put the upper limit. Upper limit is half. 1 by 4 minus half. It will become minus 1 by 4 into cos n pi by 2, because x is half. Then when you put the lower limit, that is 0. So this will become 0. This will become 0. So it will become only minus 1 by 4. Upper limit minus lower limit. So we are done with the first one. Now second part, minus 1 by n square pi square. You put the upper limit for this. So what do we get? Sin n pi by 2. Lower limit sin 0 is however 0. So we are done with this one. Now next come over here. So what do we get over here? Here we have this 1 by n pi minus 1 by n pi. Put the upper and lower limit for this one. So it will become what? 1. X is 1. 1 minus 3 by 4 is 1 by 4. Upper limit is cos n by x. Upper limit is 1. So it will be cos n pi. Now minus lower limit. What happens when you put the lower limit? Here half. Half minus 3 by 4. Half minus 3 by 4 is what? What is half minus 3 by 4?
1 by 4, ma'am.
Minus 1 by 4. So we will have over here minus of minus plus 1 by 4 cos n pi by 2. So we are done with this one. Now what is remaining? The last part, that is 1 by n square pi square sin n pi. Upper limit when x is 1, sin n pi, sin n minus second part x is half, so we will have minus sin n pi by 2. So here it's only regarding confusion regarding the terms. So you cannot directly put sin is there, you cannot put 0, but because sin n when x is half it exists, sin pi by 2 exists. Only sin n pi and sin 0 will be 0. Okay, now simplify this. What do we get on simplification? That is little confusing and trickier, but still this question is important. Let's work out. So 2 into, what do we get over here? What do we get over here? Any common term can you find? Any common term? Here 4, correct? If you take minus 4 outside from both of this, if you take minus 1 by 4 common, minus 1 by 4 into minus 1 by 5, it will become minus 4n pi. And we have cos n pi by 2 plus 1. Similarly over here you check. What do we have? This one. 4n pi is common. If you take 4n pi common over here, minus cos n pi remains. Minus cos n pi. Similarly over here, if you take this 4n pi, minus cos n pi by 2 remains. Here also 1 by 4n pi common, so cos n pi minus sign is there, minus cos n pi minus cos n by 2 remains. Now tell me what are the other terms which are pending.
1 by n square pi square they have to take common.
Okay, we can take that common. See here, minus 1 by n square pi square minus 1 by n square pi square into sin n pi by 2. These are same terms. So you can write it as minus 2 by n square pi square sin n pi by 2. So these two are the same terms over here. So minus 1 into minus 1 is minus 2, like that, minus 2 by n square pi square sin n pi by 2. So these are the terms which are pending over there. Now let's simplify this and write, this can be written as 2 into 1 by 4 n pi into, now tell me what are the terms which remain. Here this term and this term get cancelled. What is remaining? 1 minus cos n pi is remaining, minus 2 divided by n square pi square sin n pi by 2 is remaining. Now here, what finally we can write when you multiply by 2, 2 ones are 2 twos are, so 1 by 2 n pi into 1 minus cos n pi, correct? So cos n pi can be written as minus 1 power n. Then again when you multiply this 2 over here, it will become minus 4 by n square pi square sin n pi by 2. Sin n pi by 2. So this is what? This is Bn. This is little lengthier, still practice, so it will be easier for you all. So you have found sine. So what is f of x? Bn we have found out. What is f of x? Summation n equal to 1 to infinity Bn sine n pi x by L. L is 1. So it will be summation n equal to 1 to infinity Bn is 1 by 2 n pi into 1 minus minus 1 power n minus 4 by n square pi square sin n pi by 2 into the sin n pi x. Sin n pi x. This is the half range sine series. Anybody has any doubt in this? Anybody has any doubt in this? Is it okay, everyone?
Yes, ma'am.
Okay, if you have any doubt, please contact me. Remember this, practice everything. So if you have any doubt, any questions, if there are many questions in the textbook, work out. Okay? If it is very difficult for you all, please work out only what I have given. Only the questions I have discussed. Please work out only those if you are finding it difficult. But do not leave the second module. Please do not leave out the second module. It's very important. Even it is important if you are doing your higher studies. So do not leave out Fourier series. If you are finding it difficult, please study whatever I have discussed in class. Only practice those questions. More than sufficient. You will get the idea. Those who want additional problems, they can go to the textbook or you can ask me, I'll provide it. Okay? Is it okay, everyone?
Yes, ma'am.
Okay, let's meet in the next class. Thank you, everyone.
Thank you, ma'am.
Thanks, ma'am.